My name is Mary Gephardt, and today is January 14th, 2026. And in today's video, I will be going over my combined spectral problem for group 13. So the molecular formula that I was given for this combined spectral problem was C10H12O. So the first thing that I decided to do was to calculate the degrees of unsaturation. Um, right over here is my degrees of unsaturation formula. It's 2C plus 2 plus the number of N minus the number of hydrogens minus the number of halogens, all divided by 2. I did not have any nitrogens or halogens in my molecular formula, so I did 2 times 10 plus 2 minus 12 divided by 2, which equates to 5. So I had 5 degrees of unsaturation in this structure. These 5 degrees strongly suggest that there is an aromatic ring present and an additional pi bond present. 4 of those degrees coming from the aromatic ring, and then that additional one coming from the pi bond. So I began by analyzing my IR spectrum to identify the functional groups present. One of the first things I like to do is to examine and see if I have this broad, easy to identify OH group, which would be indicating that I have an alcohol functional group. As you can see here, that broad stretch did not exist in my spectrum, so I knew that there was not going to be an OH functional group. Um, right next door, I did identify a sp3CH group, and this was between 2900 and 3100. And to me, this supported the presence of an aromatic ring existing in my structure. Um, So that was the first functional group that I noticed. The second group I noticed occurred at about 1700, and it's this very strong peak, strong and sharp peak. And this is indicating a carbonyl group, either an aldehyde or a ketone, one of those C double bond O functional groups. And this occurred at around 1700. And then continuing a little bit further, I noticed a C double bond C between about 1450 and 1600. And this to me was also confirming and indicating that I had that aromatic ring. And these were the C double bond C stretches that occur within the ring. So those were the three main functional groups that I identified from my IR spectrum. And just making note that I did not identify that OH group. I then took a look at my CNMR spectrum, and the first thing that I did was to count the individual peaks that were present in this spectrum. In total, I counted 8, which equates to 8 unique carbon peaks. And this makes sense considering that I have hypothesized that there is a aromatic ring present in my structure, meaning that the symmetry that occurs in an aromatic ring would cause that um, the number of unique carbons to be different from the number of total carbons. So being that I had 10 total carbons, it's okay that I have 8 unique carbons due to the symmetry of the aromatic ring. So I first began by identifying a ketone carbon, and that occurred at 210 ppm. And this is a very easy to identify carbon because it appears the furthest downfield, due to it being the most deshielded and due to the strong electronegativity of that oxygen atom. I then noticed this group of peaks, about 4 peaks here, and this was between about 135 and 128 ppm. And I identified these peaks as my aromatic ring. Um, and I identified these as my aromatic ring, due to the location of the sp2 carbons. Continuing down, I identified a peak at about 50 ppm, and being that this was the most downfield of these last three peaks, I hypothesize that this peak specifically is going to be closest to that carbonyl than this secondary and this primary carbon. Um, and that is because when carbons are closer to that strong electronegativity, they are more likely to be pushed a little bit more downfield due to that electronegativity and the de-shielding effect. Um, and so then I had identified my secondary carbon at, or my secondary alkane at about 35 ppm and my primary alkane at about 10. So those were the eight unique carbons that I identified in my carbon 13 structure. Mm. So continue on to my HNMR structure, which is taking a look at the protons present. Um, so one of the first things that I like to do for this is to count up the number of hydrogens present and relate it to the number of hydrogens given in my molecular formula. As we can see here, I had 5 plus 2 plus 2 plus 3, and this equates to 12 hydrogens, which is the number of hydrogens that I was also given in my molecular formula, so that works. Um, so the first thing that I made note of was at about 7.2 ppm, and this was a multiplet with an integration of 5 hydrogens, and this to me was indicating the presence of that benzene or that aromatic ring. Um, so this peak right here identified that benzene ring. Moving forward at about 3.6 ppm, I had a singlet. Um, and a singlet means that there were no neighboring hydrogen atoms, which tells me that it could very possibly be located between that phenol, that benzene ring, and the carbonyl group that's present in my structure. Um, Located next to that at 2.5 ppm is a quartet with an integration of 2H. And this is indicating to me that there are three hydrogen neighbors. And to me, this determined that it was near a terminal methyl group. And then continuing at 1 ppm, I have a integration of 3H with that multiplicity of a triplet, meaning that it exists next to two hydrogen neighbors, which would make sense that the um, CH2 would be next to the CH3, meaning that there would be a ethyl present in my structure. So just to kind of go over my interpretation, I had the benzene ring on the end over here, followed by a CH2. Um, Next to that CH2, I have my carbonyl group, or my ketone group, and then followed by that ketone is a CH2 and a terminal CH3 given from my interpretations. So based on everything we have reviewed and all the information gathered from the IR spectrum, the 13 CNMR and the HNMR, I identified my structure to be one phenol, two butanone. So beginning with this benzene ring, we identified the IR spectrum to have the sp3CH groups, which was indicating that there was a benzene ring present. We identified a carbonyl group, which in turn identified as a ketone later due to the chemical shift region. And once again, in that IR spectrum, we had our C double bond C, just confirming that benzene ring. We had our benzene ring located in our 13 CNMR, our allylic carbon, which was located between the benzene ring and our carbonyl group. So there's our allylic carbon that existed at 50 ppm, and including our secondary alkane and our primary alkane over here, also known as the terminal methyl and the ethyl group, right? Well, this is our ethyl group right here. Um, so based on everything that I identified in these spectrums, I identified one phenyl, two butanone.